becoming a data architect. My name is Buck Woody. I work at a company called Straight Path Solutions, which is a consulting firm. They do remote DBA work for large and small companies, and I'm the chief data officer for our company, helping us do things like compliance and strategy and all those sorts of things. I worked at Microsoft for about 20 years, and I've taught this course multiple times. I've taught how to become a DBA, how to become a data scientist, and this is another role called a data architect. And Socrates said the beginning of wisdom is a definition of terms, so let's do that first. An architect considers multiple factors to make high-level decisions to create a comprehensive solution, including implementations, operations, security, and business continuity. Notice we did not say HADR. HADR, high availability and disaster recovery, is part of business continuity. There were many businesses that were down today because somebody hit some fiber somewhere and we couldn't get to the internet. People couldn't check into the hotel and couldn't check out of the hotel and all those sorts of things. The IT team probably wants to take a look at business continuity for that solution. And some of you, if you see someone else get hurt, it's always a good idea to make sure you find out why they got hurt so you don't get hurt the same way. So let that be a lesson. Make sure you have your business continuity plans. We'll talk about that in just a moment. All right, what we're going to talk about next, though, are the capabilities that a data architect should have. And at the risk of reading my slides, which I always tell people don't do that because you guys can read, but I'd like to go through a few of these if you don't mind. That first one you think is pretty obvious, but it's not. It says understand the requirements. Understand the requirements. You are assuming for a moment that your business is clever enough to actually define accurate requirements. I would imagine there's a few of you in here who have been in situations where the business says they want X, but in fact, you find out some weeks later they wanted Y. Everybody remember that? So the first thing I do when I get into a thing, what do you need it to do? What do you want it to do? And I write it down on the board. And if there's a term there that we don't quite understand, I make sure they define that term. For instance, I was working in a large manufacturing company, and they said, we want to have a business intelligence system. That sounds great. What does that mean? And they said, well, we need to do these things. And in one of them, they said, we need to be able to plan out our inventory. I said, what's inventory? Now, you probably know what inventory is, don't you? I mean, you know that if I have something that is for sale, that's inventory, right? Does that make sense? Do you know it took 6 weeks for us to define the word inventory at a manufacturing firm where all they do is make inventory? The reason why is it turns out that inventory is a taxable term. It's a legal term, and you pay taxes on it. And in some countries, if you order something but it's not there yet, you're still paying taxes on it. And in other countries, until it's assembled into the final unit, it's not inventory. And in other countries, if you have the parts to make it, that's inventory. And it took them 6 weeks to do that. And I didn't know to push on that term until I had gone through enough projects where those kinds of terms were not defined. So what I'm telling you, the difference between the role you may have today as a DBA or a developer, a manager, whatever you do, is that you need to stop at what you think are the most basic things, and you need to fully define the problem. There's a theorem inside physics that says the further you define an issue, if you define it completely out, if you define the problem completely out, you actually have the solution. And if you think about that, if you think of a sheet of white paper and these are the things we don't know, and I start filling in the paper with dots, the things I know, eventually the paper is completely filled and I have the answer. So many times my job as an architect is to simply keep asking questions until the answer is super, super obvious. Isn't that amazing? So literally line 1, understand requirements. Now I mean understand. So to understand, what do we have to do? It's two-way communication. You have a communicator, you have a receiver, and they are then the communicator and the receiver, and then there's the message. We've seen this before, yeah? But what we say all the time is not what the other person hears all the time. How many of you are married? Raise your hand. Good stuff, so I don't have to explain that any further. I've been married for 40 years, and I have learned the best thing to do is just say those three little words every woman loves to hear. Yes, dear, you're right. The four words, excuse me. All right. The next thing you need to do is you need to understand the options. So I want to be clear on that requirements. You're going to have to know business things. I've seen DBAs, I've seen developers. I don't care what we do here. That's not my concern. I'm a geek. I do code. An architect has to understand what the business does. And that may include taking some business classes and reading some business books and talking to the business analysts at your company and learning the boring businessy stuff. And you're going to find out some weird stuff, like when C-level people talk about spaces and synergies and we mock those languages, they mock our languages because those are chunking words. They're words that mean something to a privileged few, right? When I say something like, oh, just put that on the backbone, and you would know what I'm talking about, right? You know I'm talking about a network, and you know I'm talking about all these things that have to do with networking. The people in suits don't understand that, just like you don't understand when they say this isn't a synergy we have, and you're thinking, oh, here comes the marketing words. No, that means something to them, so you're going to need to learn to tear that apart and find out what it means. Next, understand your options. This is the geek part, and you're probably really good at something. And you need to find out how to be good at lots of somethings. You probably know a way to do something. You need to figure out what other ways are there to do this, including that company I don't like and that technology I think is flash in the pan and so on. You need to educate yourself on those options. We are 2 dots deep in this presentation, and you're already regretting coming in here. All right. Next, you need to apply the constraints. In fact, I make a T chart when I go into an executive meeting. On the left-hand side are the requirements, and on the right-hand side are the constraints. And I say, let's go. And I start writing down what they say the system must do. Those are requirements. I'm then going to go start tearing apart what those words mean. Then we get to the constraints. These are the things that will prevent us from doing that. Right? I want to buy a new Ferrari. I think I mentioned I'm married. So that goes in the constraints column. As my wife says, we're not buying a Ferrari. You don't need it. You don't even know how to play one. And I'm like, no, it's a car. But point is, there's constraints, right? You guys got to keep up. I know it's after lunch, but keep up. So the idea here is you put the constraints down so that everyone in the room is clear about what you're doing. Because the games businesses play is that there are little pockets of people that have these responsibilities, and everything you're bringing in is going to upset their apple cart, and it's also going to cause them extra work or cost them money or both. So there is a built-in resistance to any change that you're bringing in. Getting it out on a whiteboard and then typing it up in the recap notes will save you from later them going, oh, that's not what we agreed to at all. You get that down. Then you go through create a design using frameworks. We're going to talk about that. We're going to suggest some options. We're going to oversee an implementation, and we're going to coordinate functions. By the way, you're not just going to pet the puppy, right? When you come up with this grand scheme that you have, and you start working with it, you're going to have to stick with it. You're going to have to clean up the poop, feed the dog, take it out for walks. Your kids aren't going to do it. It's you. So you're going to need to do that with your system. Not only that, you're going to need to adapt as you move along. No plan survives first contact with the enemy. It's good to plan, but as Winston Churchill said, planning is essential. Plans are useless. You have to do the work, but don't fall in love with what you've created because it's going to change. Everybody okay with this? Okay, good. And then finally, we'll touch on some certifications for the architect. I have an interesting view of certifications. I've written certifications. I've taught certification courses. I have tons of certifications, all those things. But I kind of have a love-hate relationship with them. I'm a self-learner. I like to go make my own syllabuses and so on and learn things. I don't need for anybody to do that. Some people need a structure to follow to force them, oh, I got to get this done by Thursday because I'm taking the test. If you're one of those people, that's okay. Whatever it takes to get you to the knowledge you need, do that. Okay, do that. If you're not self-motivated to do these things, make sure you go figure it out. All right, those are some of the capabilities you will need to have. Let's talk about the different types that there are. There are IT architects. Now, you're a type of those. An IT architect usually deals in certain kinds of certifications and other things that have to do with just the general information technology structure. There are software architects, and these people usually deal in the art of writing software and coming up with the best way to do that. A lot of the concepts we're going to use are endemic to both classes of people. There are enterprise architects, and these are people who don't just deal in small businesses, but businesses that have businesses that have businesses. And so those are enterprises. There are cloud architects, people who know a lot about AWS or Google Cloud Platform or Azure, those sorts of things. And then there are solution architects. These are the people, believe it or not, closest to the business. It's in the title, solution architect. It's literally you give me the problem and I will give you a solution. You need to be pretty mature to be able to pull something like that off. And then this is where we live, a data architect, or perhaps there are some security specialties within this data realm. But a data architect has a specific set of skills. So looking at the IT architect, and by the way, the IT architect is someone that you'll need to know or be as well. Many companies are not going to have multiple kinds of architects as they go. It's just not going to happen. Basically, these people use various tools to communicate and document solutions. You're going to need to know, first of all, frameworks. Okay? Frameworks. So, what I'm telling you right now is the meat and potatoes of the job. Your first thing you will need to learn and impose is a framework. All of these frameworks, and I'm going to show you a few in just a moment. I'll go to a website here in just a moment to show you examples of some of these. And again, the slides will have these links. But as you're learning these, you may not implement them fully. It's rare to see someone fully implement a particular architecture, but you need to be informed by that, right? So you don't have to do it to the nth, but you need to know the nth to know where to do it. All right, here we go. First of all is TOGAF, the Open Group Foundation. Okay, I did want to show you this particular article. This is from 2022 from HCL, and basically enterprise architecture is a foundation skill for the engineering student. Okay, so you need to know how to do these things. This is important as you're going through these. Great, and he talks about some of the standards that we're talking about here. So let's talk first of all about some of the main ones. You may be, how many are in like manufacturing, banking, things like that, like regulated industries? Okay, so you may actually be in an ISO or IEC environment. If you're in Europe, you may have different standards, but you will be in part of these. These are the most onerous, which means the most rigorous and the most involved standards that you'll get to. Believe it or not, Wikipedia, a great resource for some of these frameworks. This is an IT architecture framework. So this is basically how you run things. Service management. These are the people that respond to calls to the help desk. Those kind of folks are here. This guy wants me to pay money. I don't have any money. I already told you I'm married. So we go through this. There's guidance on scope. There's other things here. You can see it goes on, and it looks a lot like a government standard, and it is. I am, and you're not seeing it because the screen is here. I think I mentioned this earlier. Thank you for paying attention. All right. Everybody's looking at me blankly like, what is he saying? All right, let me do this. Does that look better? Okay, woo. Okay, all the way over here. This was that first article, thank you, that talks about every student should be an architect. Anybody dealing with IT. Next one, this is the first one, was the ISO. And I highly recommend that you look in Wikipedia for these sorts of things. This will show you some of the standards that you need to go to. So trying to get the mouse over and look at more. Again, I would duplicate the screen and we'll go from there. How many of you have ever seen this, the Microsoft Operations Framework, the MOF? No? It was an older standard and it's really good. Highly recommended. Again, I have a resource for you where you can look at it. And it talks about how you can operate your company. And Microsoft came out with this framework, and it was used MOF 1, 2, 3, and then it ended in 4. There are different ones we have now, which we'll go through in just a moment. Here's another one, and this is TOGAF. I'm going to come into TOGAF here, and this is the different ones. And let me see if I can show you a structure. So these are the 7 levels of TOGAF. Sounds like the movie Elf, the 7 levels of Gumdrop Forest or whatever. Anyway, this shows you different things that you work on in IT and the frameworks that go with them. Huge documentation, training, books, all kinds of things that will help you do these things. I'm showing these to you now, not for you to memorize them as we're going through this, but to expose you to the idea that these things exist for you. Never do something that's already been done. The first thing I do when somebody asks me to come up with a solution, has somebody done this already? Because if they had, let's just use that. And you may adapt it, and that's fine, but never start fresh. You don't need to rewrite Notepad. Just use Notepad. You with me on that? Every time I go to shops, they're like rewriting Notepad. I'm like, what are you doing? Just use Notepad, right? Okay, so TOGAF, the Open Group Architecture Framework, really an important one. Another one I will use is in NIST. This is the National Institute of Standards. And here's basically the one they use. And they have various books and publications, all free, from the government that will show you how to run an IT shop. Did you know all this was involved in just getting a laptop on somebody's desk and them typing in Word, right? It should. This should be happening. This isn't happening, which is why you have severe outages and people waiting in line to check into a hotel. Because these things have not been done, because business continuity is all part of this. It's its own world. This is a fantastic place for you to be as a technical professional. Just an amazing job to have. Love this role. This has been one of my favorite roles, is to be a data architect. And you go through things like that. And again, this has been done for you. If you're in government, you will probably want to take a look at the NIST. Again, these are usually supersets. You're not doing all of this, but you should read through all of this and then pick out what you need to learn. Here's something interesting. You open up your favorite LLM, large language model, Gemini, ChatGPT, whatever, and you say, you are an experienced IT architect with a discipline in data development, whatever you happen to be. You have decades of experience and you own all pertinent certifications, period. Develop for me a full self-syllabus to learn what I need to know to be a data architect at my company, period. I have this background. Enter, and it will create a study guide for you. After it creates that study guide, tear that apart and say, I want you to role play as a fellow learner in this area. We're going to bounce ideas off each other, and you're going to quiz me and I'll quiz you. So you have an instant built-in training partner to do this work. Use it. That's what these things are for. They're large language models. That means they work with language well. They don't do great with numbers. They don't do great with certainty, but they do fantastic with language. Use it. Okay. I haven't been any questions in a while. Are we all good, or are we just shell-shocked? Is anyone shell-shocked? Will you admit to being shell-shocked? Okay. Good. Thank you for being shell-shocked. All right. And I think this is the last one. I can't show you that. Can't show you that. Sorry, that was too early. All right, let's go back to Slide World over here, and let's talk about some more things that you need to have. Here we go. All right, so we looked at the frameworks you need to know. TOGAF, NIST, there's one called Zachman, MOF, there's lots of them. Here's the deal. Keep ops and support in mind. When I used to be a dev lead, I would tell my developers, write your code as if, and comment it appropriately, as if the person who's going to have to maintain this after you is a psychopath that has your home address. Okay? So when you're developing your frameworks and you're developing the things you need to do, make sure you document. It's a lot of writing. Get ChatGPT to help. but there's a lot of documentation you're going to create to explain why you did something, how you did something, and more. But think about, they call it looking left, because it means look down and see what's going to happen to the next person and the next person, the security person and the developers and the workers and all those people. What's going to affect them and work backwards to that. Does that make sense? Okay. Am I showing the right screen again, sir? You're watching me? Okay, good. Next, you need to talk about two things. These are called symbolics and tools. When we talk about symbolics, it's the way we describe things. Does everyone know what an entity relationship diagram is, an ERD? Anybody not know what that is? Raise your hand if you don't know what that is. Okay, so thank you, sir. An entity relationship diagram is a set of agreed on symbols that says this is a table and it is related to this table, and it uses different kinds of arrows and feet and round circles that says it's related in this way. A DBA can show this to another DBA and go, this is our data structure. And the other DBA can look at it and go, you're missing a tertiary reference right here. It's a way of us communicating with pictures, as pictures are worth thousands and thousands of words. Okay? So when we talk about symbolics, this is the ERD you need to know, or the ERDs you need to know to do your job as an architect. One of them is a network diagram. We'll show you that in a minute. Another one is called BPMN. Does anyone use this? Okay, BPMN stands for Business Process Model Notation. And when I show it to you, you're going to be, oh, this is amazing. I love this. It's the way the business thinks about a process of things getting done. We're going to jump down to the next one, then we'll go over to the slides or the web, and I'll show you these. UML. How many of you have used UML before? A few people. Okay, I love the word universal markup language. I love it. Back in the 90s, we used to put the word universal on any technology, and it's like the next week it was superseded by something else. And I'm like we have a Miss Universe contest in the United States. How do we know that? Like, where's Jupiter? Right? I mean, you don't know. There could be very attractive people on Mars right now. We don't have that, but we call it universal. So that's the same thing. Universal markup language. Not everybody still uses this, but you should, because it's a great way. All right, let's go take a look at those symbolics. The first one I have here is from Contoso, which is a fake company that Microsoft made. If you look at this diagram, I think it'll be pretty easy for you to find the person or function that does something and what's happening, right? It's a little symbol of an email. So this person does this, it goes back up. These things here are called swim lanes, and they basically describe a person, a job, or a process that owns all the things that are in it. The lines that go back and forth are where these things are given from this function to this function. Does that make sense? So it's just like, you go to the grocery store, you ask for something, person goes to grocery store, asks for jar of honey, person goes to the back, gets jar of honey, returns it to the customer. That's what that would look like. This picture is gold. I've had people describe processes to me, and I've talked to the execs, and we're describing, and I'm like, so it looks like this, right? And they'll go, no, not at all. This is what it looks like. And I'm like, oh my gosh, that's not what you said. So when you show people these things, and tons of tools can do this, you can get BPMNs online. Visio does them. I think there's a library you can get for PowerPoint. So almost anything will create these diagrams. The symbols inside, the little symbols inside mean something. The open circle down here at the bottom means it's done. So you can look quickly for that circle. Notice there's a block in there and it says close something. And the idea there is that's another sub-process within that swim lane. Maybe another team handles that. Isn't this gorgeous? This is really useful, and you can sketch it quickly on a whiteboard and then take the picture, and then AI can make a beautiful drawing for you. I take notes on paper. I still take notes on paper. Take a picture of it with my phone, convert that to text, and then put that in OneNote if I care about it. Super quick, super easy. Use the AIs you have. Questions on this at all? How many of you know what a mermaid chart is? Mermaid chart. Oh, huge fan. For those of you that don't know, it's a JavaScript library where you say things and it draws things. and it has BPMNs, it has UMLs, and so it's free. You can view it in any web browser, and you can go online, and there are places where you can develop the mermaid charts. Little secret, if you go into Gemini especially, I found it to be really good at this. Create a mermaid chart that shows the following things. I do this thing, I give it to so-and-so, the database uploads this, it'll create a beautiful chart for you. And it's text, so you know what you can do? You can check that into GitHub and it becomes part of the artifacts of your solution. Isn't that gorgeous? You can actually check in text that is a declarative view of your graphic, which I love. As a DBA, I would love declarative views on things. All right, let's take a look at UML. I think this is a UML. Yeah, this is a UML. Again, not used quite as much as it used to be, but here you can describe class objects, and this is more for developers to be able to talk to each other. Most of you that are developers could probably read this and figure out what's going on. And that's what this is for. These are all shortcuts. These are all communication clarifiers, which is what we want to be as architects, because at the end of the day, you're communicating. Let me ask you a question. How many of you live in a house? How many of you ever built a house or had a house built? Nobody? A couple people? Okay. Did you just go out and start laying stuff down and hammering things? What'd you do first? What's the very first thing you did? I mean, other than make money to buy a house. Because by the way, the Gen Z wants to talk to you because they don't know how that happened. But anyway, what's the first thing you did? You call an architect and you say, I'd like to build a house. And I need it to have 3 bedrooms and 2 baths, and I need a big kitchen, and I want an open plan. And they listen, and what do? They draw a picture. They draw a bunch of pictures. They draw a front view, and they draw something they call an elevation, which is flat. So I've never really understood that. But at any rate, they draw an elevation. They draw these pictures. They hand you the pictures. Say, that's what you want? And you look at it and you go, no, the window's too close to the door. Can you move? Yeah, I can move. So he moves, gives you some more drawings. After they do that, what happens? Then they begin to call a general contractor to say, can you build this? And he looks at, or she looks at the plans and says, yeah, I think I can do that. And then she calls various workers that do the job, and she says, follow this plan. She's drawn a blueprint, and that blueprint has measurements. Are you with me here? It is taking the requirements that you had, notating that in such a way we're all saying the same thing, and then the contractor doing the rest of that. Now, of course, that's a perfect world. None of that really happened. You called an architect, you said something, they built something completely different, and you just live in it anyway because it was really expensive. That's just the way that works. That's reality. And by the way, it's not that far off from real architects either. I always tell people, look, I'm going to come in here, I'm going to give you a drawing. We're going to change things. It's going to cost a lot of money. You're not going to be able to eat in this office for a really long time. Your database system's going to go down for weeks. It's going to be double the price. But when we're done, you're going to want to kiss me on the lips. This is going to be amazing, right? And that's exactly the same thing that happens with a regular architect. We start with the architect, and these are the artifacts that we use, the symbolics. Let me see if I've got more symbolics here. I don't think I do. I do actually. So here's some architecture diagrams. Let me click this one because it says it can be bigger. You're meant to read that in the back row. Can you guys read that okay? You can read that? You're not meant to read this. This is an architecture diagram of what something will look like when it's done. This is a functional architecture diagram. Shows the pieces. Okay? And if I'm a business owner, I'm going to say, well, do I have anybody that knows how to write ASP.NET? Do I have someone that knows how to run SQL Server? Do I have someone that knows how to set up a web service? And so on. You see how a graphic communicates so much more than me talking and asking a million questions. Do you have people that can write ASP.NET? Do you know what SQL Server is? And so on. Do you see how this works? Okay, I think I've beaten that horse pretty much to death. Let's see if we got something else. All right, I'm not going to show you that one yet. You can't see that. Okay. That's the symbolic tools. All right, here we go. Data architecture. Now, we've come through IT architecture and process architecture. We've had to do all those things just to set the groundwork, if you will. And by the way, a lot of times these things are already done. They're running a network and so on, so you need to backwards engineer what they've got. Don't assume they'll always know what that is. Start asking questions, draw the picture. Take the picture to the next person. Is this what this really looks like? No. There's like 5 things in here they missed. Okay, write that down, go back to the first person. They're telling me it's this. Oh, I didn't know that. And then go to 15 other people. So it's a bit of a process to backwards engineer. And I always tell people it's okay. My process is this. You ready? This is the process I follow everywhere. I do this. Codify, just write it down. What the situation as it sits right now. Codify, just write it down. Step 2, standardize. Step 2, standardize. And what I mean by that is just do the same thing everywhere, even if it's wrong. Pick one of the wrong ways and do it that way. But everybody should call inventory the same thing. And the third step I call optimize. Optimize. That means make it better. Okay? Codify, standardize, optimize. I do that with everything. When I present, by the way, people think in 3s or 5s. That's the way people think. Fast, cheap, and easy, good, better, best, that sort of thing. We think in those terms, so always put your things in 3s and 5s. And if you can alliterate, which means to use the same letter for everything that you start with, that's the good old Southern Baptist preacher way to do things. It's easy to remember if you put things in the same letter. So in that spirit, what I do is this. When I come in as a chief data officer and I'm talking to your chief officers, I talk like this. Review, here's what you told me. And that goes on for a little while. And then result, here's what I found. That could be changed. That could be optimized. Recommendations. Review, results, recommendations. Here's what I think you should do and why. So again, codify, standardize, optimize. That's the process. To report the process, review, results, recommendations. Here's what we got. Here's what we probably should have. Here's what I think you should do about that. And that's the way I do it. Everywhere I go, that's the same process. I keep it simple. And you'd be surprised. C-level, when I teach a data literacy class. I teach the exact same class to a C-level group of guys as I do to high school students. And for the same reason. They don't listen, short attention spans, other things on their mind. Okay, same thing. So people that are C-level are still in high school, they've just got a better vocabulary. That one needs a nap, this one needs a cookie, that one's mad that this one took his ball. That's the way these guys work. So if you talk to C-level like that, and I'm not being demeaning, they appreciate it because they're trying to get, what do I need to do here and why? I want to make sure that this makes sense so there's value. And so that's the reason I use the 3 processes I use. Does that make sense? Okay, good. Was that useful? Okay, good. All right. So now we need to design a data architecture with considerations of basically 3 things. Storage, where are you going to put it? Compute, what are you going to do with it when you put it somewhere? And data pipelines and paths, how are you going to put it there? You may birth it there. You may write an app that drops its data in a database. Okay. You may move stuff into the database from a database you have somewhere else. That's another way. Or one system may feed another system. I may have a normalized table and I want to create a denormalized report. So there's a movement in there, there's a path. So here's the general architect. I'm going to show you the architecture center, the well-architected center, and DevOps. For your patching and so on, it's the DevOps. All right, I'm going to have to turn over here. All right, this is the Azure Architecture Center. I'll give you this link. The Azure Architecture Center, there's one for IBM, there's one for Google, there's one for Amazon. I'm just using this one, okay? It basically gives you the workloads that you have. And here's an Azure landing zone, or choose the ideology, or the different technologies you want to learn. Like I want to do analytics and architecture. So I click on that and it begins to tell me the decision points and so on. Never do anything yourself. Check and see if somebody else has done it. I read the Microsoft one, I read the IBM one, I read the Amazon one and the Google one and the open source one, and I come up with my own ideas. But it's gorgeous because it's all written down. Everything's here. Why are you redoing things when it's got it for you. A lot of these will give you a Visio diagram and a Microsoft project chart to do the work. Literally do the work for you. Do you have to use that thing? No, but it does half your work for you. And that's a beautiful thing. All right. And there's best practices and so on. This has been superseded. The one I showed you, the MOF, has been superseded largely by the Azure well-architected framework. Not to be too arrogant about what we're calling it, but there you go. And basically, this basically goes through your designs, your workload design, reference architecture, assessment, advisors, and service guides. So you can just literally go down the line here, and everything is there. And it even has lenses. You know, we're cost oriented, or we're value oriented, or we're speed oriented, or we're focused on security first, and so on. And you look at it through those. We want to make sure it's cheap. We want to make sure it's safe. Notice these aren't together. We want to make it excellent for our operations team. We want all this other, we want high visibility and so on. Everything's here for you. Did you all know about this? Has anybody seen this before? Well, this is sad, right? You know how much Microsoft spends getting this into 13 languages and keeping it up to date? Tons of money. Nobody knows about it. We keep talking about AI this and AI that. This is the stuff I'd like to see Microsoft talk more about, or Amazon, or Google, or anybody. By the way, there's probably the same thing there. All right, let me see if this one's another one. Here's another architecture example. This one for a pipeline. I'm not going to focus on that for the moment. And then they have another one, and I think I'm getting ahead of myself, but I don't care. I'm going to give you the link to this in just a minute. This was important. This is a database architecture design, or databases architecture guide. We used to call it the DAG, D-A-G. This basically says, hey, this is the kind of workload I want. We talked about workloads yesterday in my keynote. And then what you do here is you simply click on the thing you're doing, and it will tell you everything you need to do, your best practices, how to do your patching, all the work. Everything's here. All the work is done for you, so definitely check out that. And finally, I'll go ahead and spin through this, and then we'll come back to it. Here's a data ops. Here, this one happens to be for the modern data warehouse. I always find that word funny, modern. What does modern mean? Does it mean right now? Yeah. Mode is a French word. It just means of the time, that kind of. And so I find it funny. It means the right now way. I think that's interesting. Anyway, there is the architecture guides. It has your full data flows, information, components, lots of things that show you how to do things. It's a syllabus for you to learn. Even if you're ever going to do this, look at it and see how your stuff compares. Does that make sense? Did you know this was here? Okay, right? So many cool things that are out there that you just don't know exist, and it's half your work done for you already. And I love that. All right, I'm going to go back to Slide World here. Again, I've got these all linked in the slides. Hit me up on LinkedIn if you'd like to have them. Those are all the things for that. Data patterns, this is the one you might want to write down. AKA, also known as .ms, Microsoft /DAG, Data Architecture Guide. So if you go to that, you'll get to that thing I was just showing you. Beautiful tool, love it. We keep it up to date. It works. Definitely go check that out. Any questions so far? I've also been blathering on here for a little bit. Good stuff? All right, data architecture guide. Data pipelines are huge. I tend to view data in its movement. So it's either at rest or it's moving around. If I'm writing a program, all computing is just rearranging data. If I'm playing a shoot 'em up game, that's all data to me. I'm just seeing the data move around. You just happen to use the data to draw a pixel or a color or a spaceship or whatever it happens to be. I just view everything as just a coding on top of how do I move the data. To me, that's the gravity underneath. And so the idea here to me is to focus on that pipe, that clothesline, that communications channel where everything hangs off. I've got, this is my huge guide. This is a 3-part guide as well, but I don't really say this out loud a lot. I call it the comes outa, which is where it is, the goes into, where it goes, and the goes outa, which is what you look at it with. So that's basically every architecture ever anywhere. It's the comes outa, the goes into, and the goes outa. And basically, if you just break it down like that, you can begin to hang things off. And then you say, well, I don't know when to use streaming and when not. Well, if you develop your pipeline, it will just tell you. You'll see, oh, this is coming out every 10 seconds. I'm not going to load that. I'm just going to stream that. That makes perfect sense. And if I stream it, I wonder if that streaming thing can, while it's getting it, look at it. And you can. So if the temperature sensor ever goes above 50 for more than 3 of these measures, I want it to turn the air conditioner on, and so on. You with me? So that's a streaming workload. I wonder if the streaming thing could dump into a database. Yes, it could. So one streaming pipeline could take care of everything you need to the goes into part. Isn't that crazy? And then you could start doing your computation on top of that, and then your goes out as how you look at it. Cake. All right. Data pipelines. Microsoft Azure uses something called Azure Data Factory. That's their pipeline system. Fabric has a system. Spark has one. Databricks has one. Flume and other open source systems do that as well for your data movement. You're looking for data movement, data pipeline, data streaming, whatever they happen to call it in the infrastructure. And so as you're a data architect, even though I show them a wireframe of all these different pieces, I actually start with the pipeline. Where is the data I need? Where is it coming out of? What is it going into? How is it doing that? And so on. The other thing is I can start turning it colors. I turn everything red. I turn everything red. Then I go back and I look at the security. And I say, is that source secure? And if it is, I turn it green. And then I say, is the thing that's pulling that data out secure? And if it is, I turn it green. And the place it's going into, is that secure? Mostly. I turn it yellow, and so on. And I can quickly look at my diagram and I say, we've got some security work to do right here. Don't leave security as an afterthought. It's very important that you do it correctly. Very important. Where are we at? We're doing great. All right, in fact, we're early, but I'm gonna go ahead and land this anyway. Is that okay? Anybody gonna have heartburn with that? You haven't been asking a lot of questions. I usually build that in, and we will take some time for questions here in a minute. I'm gonna leave this up on the screen. There's not really anything for you to take a picture of because these are all just words. They're not links. If you get the slides, they are links. They're active links. You're still welcome to take a picture of it because you could search those terms and you'd get the links, but you don't have to do that. I've got the slides for you if you'd like them. Okay, I've been talking a lot about the architect role, how you become an architect. So you may want to ask yourself, okay, I'm a database administrator. I'm coming up through this process. What do I do? And I would say this, learn the business, broaden your options. Okay? I will also say for everyone, no matter who you are, learn your frameworks, learn your symbolics, learn your tools. You get those 3 down, you have your toolbox ready. Now you say, I'm not a data architect or a DBA. I'm coming at this from some other direction. This is fascinating. What do I do? You start out with understanding data fundamentals. There is a book called 7 Databases in 7 Weeks. It's an older book, actually, but this gentleman does a fantastic job at walking through Postgres and MongoDB and all these different database types. And he explains how to work with them. And if you follow along with him, he's got exercises. And in 7 weeks, you've learned 7 kinds of databases. Whether you're a developer or a DBA or a data architect, you now have a lot more arrows in your quiver. Does that make sense? So if you're coming from it from a different direction than a DBA, go learn data foundations, database foundations, all kinds of databases, and then come again up through the frameworks, your symbolics, your tools, and in all cases, you got to know what your business does. You have to know that. As boring as that may get, it'll freak out your executives if you go up and say, tell me what we do here. How does that work? Why do we do that? Where do we make money? How do we make money? Why do we make money? And so on. It'll freak them out. They'll think you're like a plant from the SEC, which is also fun. So definitely go check out the people you can for your business. All right. All right. Listen, thank you so much. I have one question. Fill out your surveys, all that. But I have one question. Was this useful? Okay, good stuff. Thank you for coming, and I'll see you at the next one.